This is the presentation of J.J. Thomson and his contribution to the atomic theory by Kelly Weiler and Maddie Nepple.
Thomson's education. At only 14 years old, Thomson attended Owens College, now known as University of Manchester. It provided classes on experimental physics, which was uncommon for the time. He obtained a scholarship at Trinity College in Cambridge. He also earned a Bachelor of the Arts degree in mathematics in 1880.
Contribution to the atomic theory. J.J. concluded that all matter contained particles that are smaller than the atoms that contain them. He originally called these particles corpuscles, but they are now called electrons. His discovery was the result of trying to solve a controversy over cathode rays, which occurred when an electric current is driven through a vessel from which most of the air and other gas has been pumped out. Almost all German physicists knew that these rays were neither normal light nor X-rays.
The rays were thought to pervade all space. British and French physicists thought that the cathode rays were electrified particles. Thomson was able to make a convincing argument that the rays were composed of particles regardless of what kind of metal was used as a conductor. In the next 3 years, Thomson found that corpuscles could be produced in other ways, including hot metals.
This is an example of a cathode ray tube, and Thomson discovered electrons while using one of these, and he described the electrons, which he called corpuscles, as scattering around kind of aimlessly. So here's an electron, here's one, and here's one.
Thomson's accomplishments. He was recognized in 1884, being elected as a Fellow of the Royal Society of London and Chair of Physics at Cavendish Laboratory. Thomson received the Nobel Prize of Physics in 1906 and was knighted in 1908. He was known as the man who split the atom. In 1903, J.J. came up with a discontinuous theory of light which foreshadowed Einstein's photon theory. He helped develop the theory of electromagnetism, set forth by James Clerk Maxwell, who knew electricity and magnetism were interrelated, meaning changes in one, therefore produce changes in another.